In science, we must always use the correct units of measurement. In 1999, a NASA space probe sent to Mars flew along the wrong path and burned up in the Martian atmosphere. So what went wrong? One person did a calculation in pounds, but the next person thought this number was in kilograms. In this video, we will discuss how to use units properly so that you can avoid the same catastrophic results in your exams. To begin, a unit is a standard amount of a physical quantity used as a basis of physical measurement. In other words, we use units to describe measurements for things like length and volume. There are many different systems for units, such as the metric and the imperial systems. For example, the volume of petrol or gas is measured in litres in Australia, but gallons in America. Similarly, a chef would use half a cup of olive oil for a recipe, while an oil company might sell 1,000 barrels of crude oil. In science, we need to include units with all our measurements so that people understand exactly what quantities we are referring to. This is achieved by agreeing upon a standard set of units, the SI unit system. The SI unit system is built upon 7 fundamental units. They are the metre for length, the kilogram for mass, the second for time, the kelvin for temperature, the ampere for electric current, the mole for amount of substance, and the candela for luminous or light intensity. These are called fundamental SI units because they are the building blocks from which all other quantities in science can be expressed. For example, the unit of energy, joules, is based upon the kilogram, the metre, and the second. We'll discuss this in our upcoming video on dimensional analysis. Note that each unit has its own name and symbol. You will encounter most of these fundamental units throughout Year 11 and 12. These units have very specific definitions based on physical constants to ensure that they are accurate and consistent. For example, 1 metre is defined as the distance travelled by light in a vacuum during a time interval equal to the reciprocal of the speed of light seconds. Most of the remaining units that we use in physics are known as derived SI units. Derived SI units are made from different combinations of the fundamental SI units, and some of them have unique names. For example, the unit for frequency, Hertz, is a derived SI unit of per second. That is, when a light ray has a frequency of 10 to the power of 14 Hertz, it will oscillate 10 to the power of 14 times per second. Pause the video here if you would like to read through the table of derived SI units for yourself. Let's take a closer look at the units for temperature. We should always perform calculations in Kelvin, as many equations do not work if we use other units like degrees Celsius or Fahrenheit. This is the reason why Kelvin is a fundamental SI unit. But in other situations, like when measuring temperature and in weather forecasts, we continue to use units of degrees Celsius because it is easier to understand. Therefore, you will need to know how to convert between degrees Celsius and Kelvin. Remember, degrees Celsius and Kelvin have identical scales, so a temperature change of 1 degree Celsius is equal to a change of 1 Kelvin. In comparison, the Celsius scale starts at a different point, where 0 degrees Celsius is equal to 273 Kelvin. So, to convert from degrees Celsius to Kelvin, you need to add 273, and to convert back, you subtract 273. This conversion is given in the data booklet. There are also instances where we use a combination of fundamental and derived SI units. For example, the SI unit for speed is metres per second, which means that the unit of metres has been divided by the unit of seconds. Once again, we've identified the examples that you will encounter in Year 11 and 12 physics. Pause the video here if you would like to read through this table. By now, you might have noticed that we've only shown metric units. This is because the SI unit system is based on the metric system. So, unfortunately, if you are familiar with imperial units, like feet and pounds, you will need to start using metric units, like metres and kilograms, because it is the international standard in science. Sometimes we use units that are not SI units. This table shows all the units that are not from the SI unit system, but can be used in physics. Just like before, each unit has its own name and symbol. Pause the video here if you would like to read through this table. For example, we might say that a truck has a mass of 6 tonnes, which is equivalent to 6,000 kilograms, or 6 megagrams in SI units. Similarly, we can measure long periods of time in minutes or hours rather than the SI units of seconds. Very small units of time, however, are still represented using the base unit of seconds, such as milliseconds on an accurate stopwatch. Finally, the litre is not technically an SI unit. Instead, the SI unit for volume is the cubic metre. We continue to use the litre and millilitre in physics because it is convenient when dealing with small volumes. To convert between units, remember that 1 millilitre equals 1 cubic centimetre. On the other hand, there are some non-SI units which we never use in physics. Most of these are imperial units, and you might encounter some in older textbooks. You should avoid using the units from this table, particularly in calculations, as you might get the wrong answer. Let's revise what we've learned in this lesson. We always need to show units with our measurements. This way, people will understand exactly what we're talking about. In science, we use the SI unit system, which is based on the metric system. There are 7 fundamental SI units. Each one has its own precise definition, such as the metre, which is the fundamental SI unit for distance. Derived SI units are made from combinations of fundamental SI units. Some of them have names, such as joule for energy and Newton for force. There are some non-SI units which we are allowed to use in physics. This includes the degree for angle, electron volt for energy, and minute for time. On the contrary, some non-SI units cannot be used in physics, such as imperial units. We hope you enjoyed this Schooling Online production. For more easy lessons on physics, check out our second video on units.